Hey, what's going on, folks? It's Mike here, and welcome to the Programming Language First Impression series, in which we're going to be looking at a language for about an hour or so for the first time. So, for today's language, I've got another nice surprise for you, a language I've wanted to look at for a long time, and it is the Clojure programming language. So, Clojure itself, we're going to go ahead and start from reading from the Wikipedia. Again, I've never really tried it out. I remember when it came out 17 years ago now. And again, this is a Lisp-based language, or at least part of the Lisp family. And I believe it'll be on the first sentence or so of the Wikipedia what it's about, but it is a dynamic and functional dialect of the Lisp programming language built on top of the JVM or the Java platform. So again, you get access to a lot of different platforms. I imagine this can be used anywhere, again, where you're using Java as far as the different domains, but let's go ahead and take a look at this Clojure language. Now, we've looked at some functional languages before, like OCaml, for instance. And I've used some languages like Haskell before briefly, or at least played around with it. So that could be another candidate for this series perhaps someday. But let's go ahead and take a look at Clojure a little bit and try to get a little bit of a feel for the actual syntax here. So again, the syntax built on S expressions, which is basically, let's see, a tree-like. I guess the way to think about Lisp, I suppose, is that the code is the data. So you're kind of building out these trees. That's why you see all the parentheses or brackets, again, depending on the programming language here. But that's the sort of idea here from my understanding from my programming language days. But let's go ahead and see what else we have. So let's see. So Clojure syntax is built on top of the S expressions, and they're first parsed into a data structure before being compiled. So still a compiled language. So you're getting the speed or whatever the speed of the JVM is. And let's see, it's got support literal syntax for maps, sets, vectors, along with lists. Okay, so it looks like there's a few more different data structures maybe built into Clojure. Of course, lists and other languages, famously like Python, for instance, really lean into just having a list data structure, and you can implement anything from that, essentially. So let's see, a little bit more here. Clojure treats code as data and has a Lisp macro system. Okay, so we are getting into the powerful Lisp stuff here. Lisp, I'll try to pronounce that correctly. Clojure is a Lisp 1 and is not intended to be code compatible with other dialects of Lisp since it uses its own set of data structures, okay, that are incompatible. Okay. And then since this is a functional programming language, yeah, the things that I'm expecting, a lot of immutability, for instance. I'll be curious about, yeah, I mean, one of the purposes of having immutability for safety is also for concurrency as well. So this could be quite interesting here. I'm actually quite excited to dive into this. So let's see, about its type system is entirely dynamic. Okay, interesting. Because I think in some of the previous videos, I should say, a lot of the new sort of systems program languages, and again, it makes sense if you're a systems programming language specifically, right? We've seen static typing be the sort of preferred style, I would say here. But it looks like, let's see, recent efforts have also sought the implementation of a dependent type system. Okay. Let's see. So it depends on the value. Okay, so interesting. Now I wonder if that means just the value at compile time and then it doesn't change, or we'll have to read into that a little bit. But we can see the typing discipline. So it is strongly typed but dynamic. Okay. So we will have to learn a little bit more about what Clojure does. And let's briefly look at Rich Hickey, so the creator of the Clojure language. Okay, and he had worked on .Lisp, a similar .NET platform. Okay, interesting. So yeah, 17 years ago, of course, .NET was, just, it was well out by that time, C# and other languages. So interesting to see this language also from Rich Hickey was doing some interesting work there. I wonder if there was any relation to like F# or any of the work, or maybe an inspiration from his .Lisp work here. Again, I don't know the full history here, so I'm just kind of skimming this here. Let's see. Oh, it is wordplay on the programming concept Clojure that was incorporated into a few of the other things. Okay, so that's where the name comes from, Clojure. Pronouncing it, I suppose, with a harder J there, but kind of interesting. Okay, so I think we've got enough here. Let's go ahead and see if we can get set up here by looking at the official page, and I think we're going to need a little bit more time to do some programming here. So let's go ahead and dive onto the Clojure website here. Nice clean web page here. Robust, practical, and fast programming language. Okay, with a set of useful features that together form a simple, coherent, and powerful tool. Okay, let's go ahead and get started, or at least get the download started. let's see, what do we need here? Well, okay, so there is a REPL. That's great. A read, evaluate, print loop program. So we can try out some stuff. Let's see, how can we download? I guess, oh, and there's a lot of resources. Again, something I like to look at when we're looking at these first impression videos is, again, to see, are there some good books, some learning resources if you want to dive further, if you enjoy this, and for myself as well. It looks like there's forums, a Slack channel, and so on. Okay, cool. So it looks like there's a nice set of stuff. Again, this language has been around for 17 plus years now at this point. So, it makes sense that there's going to be a pretty good ecosystem and some resources. But let's see here. How do I get this installed here? I wonder, okay, on Mac, we could use Brew. Oh, interesting. On Linux, they also use Brew, Linux Brew here. Okay, Brew, install, Clojure tools. Okay, so I'll have to install. Let's see if I have Brew installed here. Probably not. But Brew is one of those easy programs to install. So here it is, Homebrew. The missing package manager for Mac OS or Linux. Interesting that they chose this versus, using, let's say, I gotta type in my password while we go this, like apt-get or something. We'll install Brew here. And let's see what it does. Let's give it a few moments to do that here. And then I can just Brew install Clojure. Okay, simple enough here. Oh, I guess there is a Linux script tool here or something, but I'm just going to use Brew. I don't mind using it. I use Brew all the time on Mac. Quite handy. Okay, and there are other installs here. Yeah, that would be kind of interesting to only have one or two ways. This tool's been around, but again, yeah, Windows, Linux, and Mac I would expect to be well supported here. Okay, so we'll go ahead and get that installed here. Let's give Brew some time to download. Otherwise, let's look at the website here, get a feel for the language here. So again, we've already talked about it being a dynamic and a general purpose language. Okay, so again, yeah, it's not, but since it's built on top of the JVM, I'm imagining you get everything for free and can just interrupt any code. So I'd be kind of curious to hear from folks who use like Scala and Java and maybe some other JVM languages. Like we looked at Kotlin earlier. Of course, Kotlin, you have the native as well. So that's getting Kotlin's getting a different ecosystem. But let's see here. So it's compiled. Okay. Now I'm assuming again that means compiled to the JVM here. Because yeah, it makes the access easy for Java frameworks with optional type hints and type inference to ensure that calls to Java can avoid reflection. Oh, interesting here. Okay. Let's see, predominantly functional. Yep, we sort of know that. Yeah, so it's interesting to see where it belongs in this space. I mean, I guess if you've been doing Lisp, for instance, it sort of makes sense to maybe do some Clojure and then get access to the Java ecosystem. And then, for your daily tasks, I imagine, you could incorporate this into a code base, right? I guess that's one of the powers of the JVM as we're reading about it. You could use several different languages and effectively compile to the same thing. Now, does your team or management want that? That's a different question, because I'm guessing not everybody knows Clojure, but most folks can learn or pick up Java from school and such. Okay, so let's see. Performance, security, and stability is what's getting leveraged by building on top of the JVM. And it's trying to be a pragmatic language. Okay. Yeah, kind of interesting here. Why Clojure? Yeah, this is a good question. I suppose every smaller language, I suppose, should ask this question. Now, I wonder how many programmers are actually using Clojure. I imagine enough. I mean, because I've heard about it from other developers and from folks in school and so on. But let's see. They wanted a Lisp for functional programming, symbiotic with an established platform, that's JVM, and designed for concurrency. Yep. I mean, those all sort of check the boxes. The functional paradigm sort of supports concurrency, tends to support it very well with the immutability. And then if you want a Lisp here where you can just have a powerful sort of macro system, folks might like that. Okay, so Lisp is a good thing. Often emulated, pillaged, still not duplicated. Interesting. Yeah, Lisp is, I've got to consider if I want to use it for this series. I haven't done much. We could look at Common Lisp perhaps. But this language has been around for like, I don't know, 60 plus years at this point, or various dialects of it at least. And we're still always finding out that, like, yeah, Lisp had garbage collectors and all these like features that we're just getting in, languages today and considering them modern. So it's kind of interesting when you have that relationship with the code being effectively your data. So that's kind of interesting. Yeah, there's no syntax, just very small language. Let's see. So it's not constrained by backwards compatibility. Let's see. Um, let's see. Core advantages. Let's go ahead. So still code as data, and that's our sort of abstraction here. And I'm actually quite excited about this because this will be a new sort of paradigm to think about. I mean, I've been recently thinking about in some of my other series, if you watch or are upcoming on my channel, if you're subscribed, thinking about behaviors and how to abstract those, right, in object-oriented programming versus the actual data. And there's different patterns you can use, for instance, like a visitor pattern, to kind of think about those things, as well as just the things that you're using in an object-oriented or procedural language. So this is just, again, another way to sort of think here. So again, functional programming being a good thing here. Let's go ahead and check in this download. That's finished. So let's try to brew install. Okay, it says brew not found. Oh, next steps here. Let's read the whole installation here. Run these 2 commands in your terminal to add homebrew to your path. Okay, I'll do this. Let's see here. Let's do this. Yeah, I'll go ahead and paste it in here, and let's get this one here, and then let's see if that works. And I have the build essential tools here. Okay, let's do that. Brew. Okay, it is there. So let's do brew install Clojure. And we'll just give that a moment to download. Let's see. Functional programming, again, is a good thing. Yeah, I mean, we're seeing a lot of modern languages take up after this for sure. So you get your immutable data, first-class functions, being able to pass functions inside of other functions. Yeah, it could always be done by Lisp, but yeah, it just depends on the discipline or the convention. Let's see. Pure functional language tend to have strongly static types. Interesting. Not for everyone or every task. Yeah, I mean, this is one of the things here. Again, as you folks also know, I do a lot of deprogramming on this channel. Going too strict sometimes affects the sort of plasticity of your code and forces you to, makes refactoring a big deal or even kind of discourages it sometimes. So, I mean, this is just an interesting sort of psychological thing. I like static types. I tend to like strongly static type systems as well. But again, yeah, not for everyone or every task. And I think there's probably some interesting contrast here between safety, how we refactor, performance, some of these different trade-offs that we take here. Okay, so we got the dynamic emphasis. And VMs, not OSs, are the platform of the future. I mean, yeah, I don't know when this web page was written, but if this is how they're thinking again 17 years ago, I mean, Docker's kind of taken over. Virtual machines, I always tell folks to, install or know how to install. Yeah, it makes a huge difference on the set of different, facilities that you could have, the third-party ecosystem and so on. This is, a good way if you're going to make an argument about virtual machines, some of the benefits that you get here. I like things like garbage collection. JITs can do interesting stuff like optimizing code on the fly, for instance, with your profile get optimizations. There's all sorts of interesting stuff here. I can always argue it both ways here. And let's see here. Oh man, this is gonna cause controversy. Object-oriented is overrated. It just depends on what system that you're using. I think inheritance is not the only way to do polymorphism. I think that should be taught more. I try to make an effort when I bring up polymorphism that there's, at least runtime and static and compile time, etc. Some different types of polymorphisms to consider beyond objects and, function polymorphism. So that's kind of interesting here. So interesting. Yeah, it's better to have 100 functions operate on one data structure than to have 10 functions operate on 10 data structures. Sure. So interesting. Okay, so let's see here. Polymorphism is a good thing, though, they're coming to say here. But yeah, there's different ways that you can get it, right? You can sort of get it with, like, we sort of see, like, with generic programming, like on variants and subtypes, for instance. for yeah, structural matching and like patterns, pattern matching. Yeah, that kind of makes sense here. Okay, and then the concurrency stuff. Okay, so I think we've got it here. I think we've got, let's see if I type out Clojure. Looks like we're getting something here. Let's see as it's getting set up here. I think we got a feel for, yeah, some interesting insights into the development and design of Clojure. Let's see if we can find a little getting started guide though, or back here. Let's see, we've installed Clojure. I'm going to skip the editors. Emacs, of course, so Lisp inspired a text editor. Makes sense that that would be sort of supported here. We're going to use Vim here for us, because you folks know I'm a Vim person. Just because that's what I know, I guess here. So let's get tmux fired up here. I'm going to fire up Clojure here. Yeah, it looks like it's got the latest version installed here. Kind of neat here, actually. Let's get our Clojure help page here. See what kind of stuff's going on here as far as package managers and different things here. Tons of different options here. Okay, way to start. We can just execute some code. Interesting. We'll have to learn a little bit about this ecosystem here. But let's see here. Structural editing. Okay. So this is kind of a neat... Okay, let's take a little look at this here. Again, kind of going through here. Text editors treat files as lines of characters. Sure. Yep. Common functionality involves typing new characters, navigating up and down. And we sort of operate at one character at a time. When we examine the Clojure code, we know it can be viewed as a nested set of forms where each level nesting is a collection with a beginning and an ending here. Let's see here. The regular structure forms a tree, and structural editing is a new set of operations for manipulating our code at the node level instead of the character level. I mean, this is just this kind of makes sense with Lisp-based languages. And I've seen this. I've had some students actually demonstrate this to me before. Let's see if there is an example here, or I can search for one. Let's see if I bring in another window here. This is just a first hit on Google. Structural editing, one of the first edits here. Let's see here, like selecting things. Let's see what's going on if we could get like a animation or something here. Let's see what's going on here. Okay, we're taking this code, quick brown fox, taking this structure. Let's see what's going on. What are they doing? Creating things. Let's see them create stuff. Okay, so they're just kind of making interesting changes to the code. I mean, if you're changing the actual structure since the code is the data, I suppose that's, you know, just kind of editing stuff here. Okay, so I'll have to get a little bit more sold on this structural editing. What exactly do they mean by this here? We start focusing. Let's see. Oh, I see. Maybe they're just talking about, of course, we've got the balance parentheses and these types of things here. I was looking for more of like a visualization or something. I had seen some cool visualizations of structural editors. Let's see, animated parroted. Okay, that's what we were just looking at here. Okay, maybe this is... Oh, I guess this is just giving us 4 options for opening, closing indentation. Interesting. I guess it's just giving us, I mean, since this is the code here, it's giving some shortcuts for working with code here. Okay, so probably, you know, these probably fall in the like mastery level things here if you're doing Lisp and more Clojure programming. So let's go ahead and move on here. Yeah, let's just look at the REPL here. Let's get a little introduction here, and you know, just try to get a feel for the language. What's this guide gonna cover? Okay, yeah, we want to look at like the first 2 chapters or whatever. We know what this is here. Why use it? Again, yeah, fast prototyping. You can probably run some test suites, one-off commands, debugging, etc. Yeah. I like that languages, and this is smart here to have a REPL, right? Fast feedback, especially when you're learning, this is super important. It's actually probably an invaluable tool for helping spread the adoption or getting folks, you know, like me started in the language, to have some of these tools here. Okay, so let's launch a basic REPL. Now let's see here. So I could just type out Clojure. I'm on version, what was I on? 2 or something? Let's see here. Clojure. Well, we'll find out here. 1.111. Okay, so maybe 2 versions ahead or so. So we got something relatively modern. Okay, and let's see. You can exit by doing Control D. I was doing Control C to terminate. That's okay. Let's see. We don't need any project management or boot. Okay, let's go into our basic usage. Okay, evaluating Clojure expressions. Yeah, let's try something here. +2, 3, 5. Okay. Now again, immediately this is always weird syntax to folks here. And I remember writing a little bit about this sort of form here. And, you know, this is the thing with sort of functional programming, I think. Again, we sort of evaluate this as 2 plus 3 in our head. But if we start thinking about plus just as a function and these as the arguments to plus, and this being like a variadic function here, which I wonder, let's see, how can I do the previous? Control P maybe, or Control Shift P? No. 2, 3, 4, 9, right? This is basically just a variadic function where I can, you know, take in the arguments 2, 3, and 4 and evaluate them or apply them with this plus operator here. So again, a little bit different way of thinking about things here, but you know, if you just think about this symbol as a function, it's like in C or C++, right? I sort of teach ampersand is just a function to get the address of something. That makes this a little bit more clear versus trying to put the plus sign like in the middle here. I've always wondered why tutorials show it like this when they should probably show 2 examples. So we'll see if they do that as well. But let's look at some more stuff here. Yeah, let's write our own function. Factorial, classic one. Okay, so we're going to, again, everything's going in parentheses here. We're going to define the factorial n here. So I'm assuming that's the argument that we're going to provide, right? Which we, you know, could put spaces in between. Let's say if, here's our base case, n is 0. We're going to return 1. Now let's see here. I got to be careful with my indentation, I suppose. Or maybe it doesn't matter. Otherwise, we apply, let's see, n times factorial. Oh, and what's this here? We got a dec n instead of like applying. I mean, that's just a handy function to have. All right, we want to decrease our n. 1, 2, 3, 4, 5 parentheses here. We got to match these up here. So match, match, match here. And then we got to close out our function. I'll hit enter. Okay, and then it created this factorial function for me. Okay, I was wondering what that was to type in here. And now I can just execute this factorial. Let's do a 10 here. And we get the result here. Okay, very nice here. Again, the thing to probably get over is the syntax here. But again, functional language is usually pretty concise here. I actually kind of I'm liking this Lisp here. And again, I'm already getting excited about Clojure here because, you know, I think one of the hard things for folks to do is, you know, to be told, hey, you need to learn Lisp because it's good for you. You know, you kind of think about programming, it's got all these features and so on. And I think that is true, right? That all programmers should learn different types of programming languages that enforce different paradigms. That's how you get, and then whatever language you choose, that's your favorite, you'll be able to think in different ways or approach it with different patterns. But again, I think the nice thing with Clojure is here, if you say, and this is also true for Kotlin or Scala, but Clojure more so since it's teaching you this. I'm imagining, right, this factorial program, right? I can compile this to something on the JVM and make use of it, right? So it's not like, it doesn't feel like a sunken cost, right? With the sunken cost fallacy, even though, again, that's a psychological thing. Getting a lot of psychology today, but so that's kind of nice here. So I'm liking this. I'm appreciating this. Taking a look at Clojure here. Yeah, I mean, there are basic examples here, but yeah, that's fine here. So 2 flavors of printing. Okay, we got a print line function here. Let's see here. Print line. That's in hello. Hello, YouTube from Clojure. Let's do that here. Okay. We get this value, and I guess it's inferred the type here. Nil here. Okay. So this is strange. Unlike the previous example, it looks like evaluating the print line expression yields 2 results. Okay, and nil. Let's see, did we miss a previous example here, printing out? No, I guess just from the factorial, we just got 1 example here. Let's see, so 2 flavors of printing. Okay, so we did this. We got the 2 values. Print line function prints its arguments as standard output, but returns nil. Okay, yeah, that's fine. The result is just nil here. Okay, so we could check that. Okay, interesting. Okay, let's see. Calling Clojure libs or libraries from the REPL. Okay, so far these are the built-in functions that we've defined, but let's go ahead and add some power here. Okay, so it requires going to be our code here, and then our namespace seems reasonable enough here. Okay, so let's kind of keep going on here. Require, and we're going to add in the Clojure string library here. Okay. Okay, let's see what that gives us here. Okay, so I guess it require lets us define an alias for Clojure string. Okay. Namespace by adding an as clause. This enables us to refer to names and then Clojure.string namespace more concisely. Okay, I was going to say, where is that? Yeah, let's do this. Now, how do I go back on the editor here? Up or down don't work. Let's see here. Maybe a quick Google. Google tells me if I type out CLJ, then I get a more powerful REPL here, where I can do the uppercase key. Okay, so I'm going to go ahead and do that. So make life easier here. Just save us some more time. So CLJ, I guess, is a Clojure command line version that lets us do some more stuff here. So let's go ahead and pick up where we left off here. Get that alias here. Require Clojure string as, okay. And then let's actually use it here. Okay, so here's our function here. String uppercase Clojure. Okay. Oh, simple enough here. Now this is kind of interesting. Again, since I'm not as familiar with Lisp dialects here, right, where you see a slash, usually we'd see like dots in a language here. Okay, cool. Let's see here. Because you don't usually see that or think about that as like a name identifier or whatever here. Let's see what else we got here. So finally, if we're very lazy and don't want to type an alias at all, we can add a refer class. Oh, interesting here. Okay, so this just returns us Clojure string here, no alias, and then we'll just go ahead and, let's see, use uppercase there. Okay, that's fine here. Let's see how to get a little bit of help here. The REPL can also be used for looking up API documentation using the REPL lib. Okay, so let's go ahead and do that. I was going to say, how do I get help? Because I kind of wanted to see if these functions here, like, I mean, this literally looks like a URL or something. If I can quickly get to it, if the documentation structure reflects that there. Clojure, REPL, okay, refer all. Okay, so we get to practice that experience. Oh, okay, then I'm just literally applying a function here. Returns true if x is nil, false otherwise here. Okay. Let's go ahead and try another one here. Doc uppercase, and then a question. I don't know. Nil. What about, let's see, string uppercase. Okay. Oh, and it gave us sort of a best match here. I didn't type it out exactly. Convert string to all uppercase. That's pretty good. I think it's just giving us like the closest match here, like with 11 distance or something. Okay, cool. Let's see. So nice. Okay, and I could also view the source. Oh, even better. Okay. Source sum. Okay, it's at some. Cool. Now that I like here. Hold on. Let's go ahead and do that stir uppercase again thing here. So now we can actually see how this is implemented. I mean, this is a great way to learn the language too. I would like to see this feature. So again, just making a mental note for myself. Clojure, very cool. I can actually see the source code of the actual standard library functions, which is really cool. And then in OCaml, we saw a really cool, like if I started typing, it would sort of give me hints for stuff in the REPL. So the functional languages are really doing a great job with these sort of built-in REPL environments. So I'm very impressed with that. It can be, and again, we're 30 minutes into this video. Sometimes just these little things from looking at enough different tools are gold nuggets in my mind. So that really is one here. Because I think as a learner, this is just amazing to see, like, okay, what condition did you get into, whether it's your code or maybe somebody else's library code that gets exposed, that you can actually see the code here. So that's awesome. Let's see. So I can use dir to list the names of all the variables in a given namespace. Okay, so let's keep playing with this here. Looks like I'm just going to do everything in the REPL. Dir Clojure string. Okay, cool. And again, this is like in Python, you have this as well to see all the different, functions or families of functions in this namespace or the objects or whatever. So again, another winning feature. I love when there's easy ways to get help in a language, right? If I can just pop open a terminal. Again, that's super useful. If I'm often in a plane or a train or something too, you don't always have internet connectivity, and speed is everything, right? The latency matters, where you can get help very quickly here. So yeah, let's see what else we can do here. Clojure. What else is in the REPL here? Here, let's go ahead and clear that. Apropos, which is like in the Linux system. Let's go ahead and try that out. Apropos. Let's see if I do tab. Auto completes. Beautiful. And what do I want to do? Stir uppercase. Let's see here. Maybe, let's see. Nil. Yeah, I don't know here. I guess now this one here. Let's see. Syntax error. Okay, well, we got to learn what the question mark is here. Apropos on Unix systems is like the man page, effectively the manual pages. But we got source and some other interesting stuff here. Okay. Doc, source, and dir. Perfect. Oh, if you don't remember the exact name of some variable, you can search for it. Oh, okay. It takes in a string as a parameter here. So let's see. Okay, perfect. That's kind of giving me some hints there. Very handy. Okay. Find docs and more tools here. Yeah, A++ for the built-in documentation stuff here. Data visualization in the REPL. Oh, cool. Okay. Okay, let's see what else we got here. Let's make this a little bit bigger. It looks like we're getting into interesting stuff here. So each time we evaluate expressions, the REPL, it shows us the textual representation. Okay, most of the time that's clear enough, but sometimes it could be hard to read. Okay, so we have a pretty printer effectively here, pprint here. Okay, now let's see what's going on here. Well, looks like we got to write a new function here. Let's go ahead and try to write it. Looks like our biggest example here. So we're going to define a new function, number summary. Okay, let's see. Oops, I hit tab here. What has happened here? And then I hit Control-C because I panicked. Okay, but I can still go up after I quit here, so glad I did that. Anyways, let's see. That's our argument. Let's see. Let proper divisors into. Ooh, can we do this without making a mistake? It's gonna be a good question here. Let's see. Filter. Try to give myself some indentation here. Function. I guess that's a higher order function here. We're passing as a parameter somewhere 0. I'm gonna really have to think about this example here. Let's see. Remainder, the number and divisor. Okay, so we're doing some sort of division here. And the range, 1 to n. Now I think it's auto completing my parentheses for me, which is good. Let's see, divisors, sum. Okay, we might have to copy and paste this in here. Proper divisors. But just getting a feel for the language. Now, let's see, we got new stuff going on here with the curly brace. So what is going on here? Still got to learn a little bit more of the language. Is this doing the proper divisors? Is this doing a pattern match? Let's see. Even. Got to get a little bit of a feel for it. If it's prime testing, let's equal. And this is maybe taking in an argument. Now I've seen that pound symbol mean string interpolation, so again, we got to learn here. Divisors. All right, let's see what happens. Okay, we typed it out correctly, which is, a small miracle. Let's go ahead and try out. Okay, we see a map function. So map usually means apply something to some set of things here, and v maybe a vector here. Again, you know, and maybe this isn't the right example to start off with for a beginner, but it's kind of interesting. Okay, I see the point here. We get a bunch of stuff here that's wild here. Okay, now I see. Okay, so let's try this again. Yeah, it's very hard to read. I don't know anything what's going on there. So let's try to incorporate our pretty printer here. Pretty printer as PP here. Okay. Okay, so let's now, okay, apply this function here. Pretty printer, that's built in. And then do our map to, I'm assuming, the vectors on this number summary. Let's see, 5, 6, 7, 12, 20, 42. Okay, let's see how that improves things here. Oh, and the CLJ is doing a nice job helping me match up the parentheses here. Okay, that's much better. Immediately, we can see what's kind of going on here. Okay, and it's collecting the proper divisors. Okay, for these functions or what they're divisible by, I guess. I don't know. Interesting. Okay, very interesting. Try using your editor here. And syntax highlighting the results. Okay, I'm guessing I can highlight over this. But yeah, nice more functionality here. Let's see if we can get a little bit more into the language here. We've seen a lot of the neat stuff here. Okay, so there are exceptions that we can handle. I mean, this is on the JVM, so we need to be able to handle stuff, right, if it goes wrong. And it looks like there's other sort of interesting web-based visualizations with JFrame. Okay, cool. This is giving me a good experience with the REPL overall, but let's see if we could get to some of the just learn Clojure stuff here. Which, I mean, we've seen functions, we've seen some of the variables, but let's try to zoom through some of this again just to get a feel for it, and maybe we'll try to copy and paste some of the examples. Let's see, so we've got our basic types here. Oh, interesting, ratio versus like a something else here. That's kind of interesting. I wonder, again, more of a Lisp thing, right? Rather than dividing and introducing some error, we actually produce a ratio. So ratios are provided as their own type combining a numerator and a denominator. That's interesting. And I wonder if that's a way that we don't lose precision. Right, if I took a ratio of 22/7 and multiplied it by 7/22, that we would always get exactly 1 versus, you know, potentially like 0.999 or something. That's interesting. Let's see what else we have here. Floating point values, okay. Standard stuff. We got regular expressions built in. Okay. That makes that easy to use. Symbols and identifiers. Yep. So again, yeah, like plus we know is multiply, nil for the types, true and false. Alpha and okay, keyword with the namespace. I see. That's just giving us some how names or symbols are the rules. Literal collections. Let's see here. Okay, let's see. So built-in list, vector, set, and map. I see. Okay, so in that previous example, just to get some code in front of us, we were building a set here. Okay, that makes sense here. A little bit more what was going on. And then, of course, a map with the colon. Okay, now we can actually read this. Okay, so glad we went out of... I guess we went in a lucky order here. So for 5 here, right, here's the map for 5. I mean, you can almost read this when it pretty prints like a JSON file, right? Just effectively a map here. It's giving us the divisors for 5. 6 is dividable by 1, 2, and 3. 7 is dividable by 1, and then it's returning true, false, or prime. Okay, that's actually quite beautiful. Now that we can see the output here, and we can see the map data structure, we can see the vector data structure, and then we can see the set here, the set of proper divisors. And that makes sense, right? We don't want repeats here. Let's actually go back and look at that function just for a quick second here, now that we kind of understand it, what was going on here. Pretty powerful stuff here. I mean, here's the value that we're evaluating. And if I've got, let's see, an argument, I mean, this is just a list, or excuse me, a vector here, n, tells me I can take in several values. And then we compute the proper values. We've got the built-in filter here. And then I guess these are also built-in functions to tell if the remainder is 0 or not, then it's a proper divisor. Okay, that makes sense here. the numerator, and then the divisor. Okay, now I understand. So I can stare at that a little bit. Now, how long would it have taken me to write that code without help? A little bit of time, certainly. But I understand the example and what it's generating now, which is really cool. And this is kind of cool. Some languages, for instance, again, like I use D, so we get vectors, vectors, dynamic arrays, we could call them, and maps for free. But kind of interesting to see other languages, could maybe introduce more syntax to introduce a set data structure or a list. So then you'd have effectively 4 here. This is kind of an interesting way to do it here with a little quotation here. I actually really like that, to kind of delineate between a list and a vector here. Now, I wonder if you could do just, the little tick mark or the single quote here, in some of these other languages here. So, already interesting stuff here in Clojure. I like that here. I'm going to hold on to that idea for a little bit. Because I think that'd be quite neat here. Okay, so let's see. We're going to talk about these more in later detail and so on. Okay. Let's see. Now we can consider our Clojure reads and values their expressions. Okay, so we got our source code, compiles it in the bytecode, and then the JVM. Okay, so not too unfamiliar for folks here. But they're doing a nice job kind of explaining things. We're probably just going to live in the REPL today, as far as this goes here. But interesting to see here. Also, very nice. This makes a little bit more of an example, right? Here is our operator here. Now that we're in parentheses, right, we know that this is a list. So yeah, now functional programming makes sense. Again, if you've done some like Scheme or maybe ML, again, OCaml stuff, this should be kind of familiar stuff here. But I'm liking Clojure quite clean here. Maybe we'll have a little bit of motivation to take a look at some other lists, but this is getting my Lisp fix as far as this series goes for Lisp-based languages. So very cool. I'm going to be curious to hear what you folks have to say about Clojure, or if any of you are actually using it. Again, what resources to look at, how you're enjoying it, what domains you're able to use it in, and if you are able to mix it properly or effectively with your Java code bases. That would be kind of curious to find out about. Okay, here, Clojure basics. Okay, and we did some of that here. Let's see here. Wow, I must have skipped a bunch of this stuff here. I guess there were some repeats, but functions. We looked at these here. Functions that can take in different number of parameters, so different arity, as allowed here. Each arity has a list. One arity can invoke another. Yeah, I mean, this is all kind of cool stuff. Variac functions. Let's see, the beginning of a variable parameter is marked with an ampersand. Okay, if I can take more than one parameter here. Okay, so I wonder, again, let's see here, source and then the plus. Okay, so if I do that here, let's look at the definition for plus. We just learned ampersand does something for the arity here. Let's see here. Beginning of your variable parameter is marked with ampersand. Let's see. What's that mean here? Functions. If I just look at the plus, returns the sum of numbers. Let's see, does not auto promote. Okay, and see if it tells me what I'll throw here. That's useful. Inline. What is going on here? Okay, so if we have nothing, then the sum is just 0. X, we just cast to its number type and then return X. X and Y. Okay, then I wonder if this is like capture the result and then just recursively call add X and Y again. Oh, I see, and more. Okay, cool. I just wanted to see if there was an ampersand. I mean, we could certainly compute add with multiple parameters, but there has to be at least one more case here. Interesting. So reduce 1. Okay, interesting here. And then take the rest of the vector in this case. Okay, makes sense here. So little subtle things here, but a very concise language, which makes sense here. Okay, anonymous functions. Functions that are unnamed here. The message and so on. Okay, let's see here. Okay, so here's another question that came up. Definition versus function. Defining new function, and the fn defines the function, and def binds it to a name. I see. So for the anonymous functions, you just have fn here. Okay. So if you want these locally, or to just return a value or something, or as a parameter type, yeah, it makes sense. Actually, I kind of like that. I mean, that's very clean here. I like that there is, some languages just have, def for everything, def for the definition. But having some differences between them is kind of nice. Again, if you're just doing Control F for DEF space versus DEF space. So again, clean syntax. I wonder, I mean, Clojure looks like, this is probably true of Lisp variants as well, pretty easy to parse as far as the actual language goes and the compiler construction goes. Again, could be wrong about that, but it seems pretty clean here. Okay, and then you got the percents for the various parameter values. Okay, because we did see that previously, at least in one example. Okay, so let's see what else we got here. Applying functions. Okay. 0 or more fixed arguments. Okay, yeah, it sort of makes sense here. These are all the same here. Okay. Apply is useful when arguments are handed to you as a sequence, but you must invoke the function with value in the sequence. Okay. Locals and closures. Okay, so where the name comes from here. Okay. And then some Java interrupt stuff here. Okay, cool. We got a little quiz here. I'm kind of afraid to take that here. But I like that. That's actually kind of nice in a getting started guide to get some feedback. Again, another thing that I might steal and apply elsewhere. I'm kind of neat here to see this. So let's go ahead, and I'm just going to kind of zoom through a few of these different help pages here. I want to just see the concurrency stuff quickly. But let's see here. The sequential collections, which have to do with vector stuff and lists. Cool. Nice, concise page. We get our main data structures here. And then sets, and let's see if they call them maps, or if they, again, a hash table, again, as it's also going to be known as well. Okay, so it looks quite nice here. Again, pretty concise page here. So you can play around with those data structures. We've seen what they've looked like. Let's see, flow control, if-else statements, looks pretty similar. Let's see, if. Let's get to deal with these question marks here. I mean, again, I'm going to assume that's just a function that returns true or false. If true, false. Okay, impossible. Okay. Yeah, again, very Lisp-like, but very concise. You gotta match your parentheses, so important to use for a good text editor. And then we've got loops as well. It looks like some sort of loop here. And then when, which we've seen in a few other languages that some languages seem to be borrowing, which is neat. Okay. Closures for, okay. Let's see, and then we've got recursion. Yeah, some languages you explicitly mark recursively, how to handle this, which is neat here. Okay, so I think I got a feel for the language here, and we looked at namespaces a little bit here, and I'm assuming this is going to kind of show us how to create our own or import from Java directly. Neat. Okay, let's get back to the guides here. Just want to, before we close off here, let's look at the concurrency, or maybe threading. This might be what we want here, threading macros. Let's see. That at least gives us one sort of model here. The thread first macro, known as arrow macros. Okay, so if you thought you were going to escape the arrow, it's pervasive in C++, for dereferencing. Here's the thread first macro. Pure functions. Okay. Okay, transform, taking initial value as argument, threads it through one or more expressions. Okay, interesting. That's pretty clean. I mean, there's no like specific function calls we have to know about or anything. So that seems to be pretty reasonable here. Note the word thread in the context is unrelated to the concept of concurrent thread. Okay, so maybe we didn't find the right page here. Let's see, where is their concurrency? I was going to say that'd be weird if they just had sort of thread-based concurrency only. Let's see in their guides. Let's see, language. Might have to, oh, I guess we've got the async module here. Okay, using channels. Okay. Let's see if they have a little example here. Okay, so they create queue-like channels. I mean, this is sort of similar to, I mean, this is looking like Go style concurrency, I suppose, here. Oh, and then they do have threads here. Okay. And blocking take here. Oh, interesting here. Okay, so this we might have to digest a little bit more and take a look at here, but thread-based concurrency, pretty familiar with that. Channels, getting more familiar with, again, you know, inspired by Go and some other languages. They have a Go block here. Let's see. Asynchronously execute the body and a special pool of threads. Yep. Okay, so pretty efficiency. Let's see. One killer feature for channels over queues is the ability to wait on many channels at the same time, like a socket select. Okay. This is done with alts. Ordinary threads or alts in Go blocks. So you create a background thread, probably have a bunch of threads, you know, doing asynchronous work, and then have them blocked, and then take a set of operations to perform on one of those channels. Okay, this is pretty cool. I mean, this is, again, pretty concise stuff here. Let's see, it's doing a read high from, you know, something and read there from. Okay, cool. Okay, so just wanted to take a little bit of a look here at Clojure. Again, we'll take a little bit of parsing again, thinking here. I found, I think it might be useful for myself even, you know, I've done a lot of concurrency work, but to probably look more at functional programming languages, and maybe that's something, again, a takeaway for you as a listener here, to maybe do a little bit of a deeper dive here, and I'm going to probably take a look at some more Clojure stuff or find a good, you know, tutorial on this. I think it might refactor or really reshape how I think about threading in other languages. Again, I've mostly done threading in Java and C++ and a little bit in D as well at this point in time, but I think that's you know, probably not a bad way to go about it. So let's just go back to the homepage here and kind of wrap things up. I mean, hopefully you enjoyed this series. I really enjoyed this. This is the most you know, Lisp-like language we've looked at, I would have to say. I mean, it was directly inspired from. Really nice REPL environment, really clean syntax, again, coming from Lisp. And it seems to integrate quite well with Java. It kind of makes things really easy for us here. So this was quite nice. And I'm actually really happy to have taken some time to look at Clojure after so many years and actually learn a few things here and a few takeaways that, you know, I think other programming languages should probably adopt. You know, some things from the REPL environment that I thought were very clear. Probably some things on the data structures that I thought were really neat and concise. Again, just being able to use those with just a tick mark or a pound symbol or whatever to declare different lists, maps, sets, and the vector data type, which are honestly the 4 types that you honestly need most of the time. Now, one thing that might have been interesting to look at in Clojure would be like a tree type data structure, again, to see the nested parentheses, the code as data. I still want to get a little bit more of a feel from that. I'd be curious, you know, what resources you have that might be good to show building trees and Clojure. I'm sure there's probably something in the guides or other tutorials that we could look for, but that might be the next steps for you, or again, if we did a second video on Clojure, what to start looking at. So anyways, with that said, folks, I hope you enjoyed this lesson on the Programming Languages First Impression series, taking a look at Clojure. And as always, let me know what great things you know about Clojure that the community should otherwise check out. And as always, thank you for your time and attention if you made it to the end of the video, and I'll look forward to seeing you in the next one.